Welcome to Week 8 of CNST 1731. This week we're going to be discussing exteriors and elevations, insulation, and something that is abbreviated MEP HVAC, and we'll discuss the meaning of that abbreviation shortly. Let's begin with exteriors and elevations. What's the purpose? Well, the purpose of the exterior is to be an enclosure to the structure. It's keeping out air, water, and water vapor. It has to have durability because it has to withstand the various elements: sun, wind, rain. It also provides us information on access and egress, how to get in and out of the structure. And it gives us information on how to construct the look of the building, the aesthetics. And we see that information in elevations, which, if you remember from earlier, is an elevation, is an orthographic projection of a feature. Basically, it is looking from the side. Here, for example, is a floor plan with elevations. By showing the side of the house, we are completing an orientation of what the house looks like. Eventually, this will show that the finish that is on the exterior, in this case from the brick veneer residence, that it is a veneer, basically a coating of brick. The building is not made of brick, but there's a covering of brick. It'll also show that there are wood trim pieces and wood siding included in the finish of the building. We also see doors and windows, something that for the most part cannot be seen, or at least not seen in great detail, in the plan view. The exterior, or the elevation, is going to show what the building will look like from the side. Here's the Shaw Place condominiums, and sheet 8.2.1 will show in drawing format the view from the left front, the right front, and the right side, as if we were standing here on the street looking at the building. The left front and left right will be joined on the drawing by a match line, telling you that this side connects to this side at this point. Now, some of the exterior features will be shown in a symbolic way. Individual brick, for example, is rarely shown on prints nowadays. Once upon a time they were, but it's a very labor-intensive way of drawing. So when brick, for example, is going to be used, they will simply shade the area and label it that it is face brick. You see here we also call out for flashing, which we discussed under roofing. The roof here is copper and metal louvers. Notice it's by the HVAC contractor, and again we'll explain that definition shortly. When we are in a larger scale drawing, either in a view or a section, then we will show the individual bricks, especially where there is a particularly decorative pattern that we want the brick to be laid out in. Now, brick can be laid in various positions to get a desired decorative effect. These are the different types of positions, and the organization of them is known as a bond. And these are the different types of bonds that are available to provide a decorative look to the brick. And these will all be shown in an elevation for an exterior drawing. Sometimes stone will be classified by the bond that is created by the stone arrangement. They can be random, coursed, broken, and so the range is a course of any thickness that's extending across the face of the wall. But all courses don't have to be the same thickness. So for example, a coursed bond is created with stone that's arranged in courses or ranges with vertical joints aligned on alternating rows. So let's take a look at an exterior drawing. This is sheet A2 of the commercial building. And we're going to look at the rear elevation and the front elevation. In the rear elevation, it calls out a building brick to be used. Notice these are simply straight lines to denote that this area has brick, but the type of brick is called out. Notice that the elevation also shows window arrangements, redwood frames, insulating glass. We show here two doors, otherwise known as man doors, because people can walk through them, and that's what they're designed for, as opposed to an overhead door like this that might be used to drive a car into a garage, for example. The little dashed lines here culminating in a point here indicates that this door is hinged at this point. So the doorknob would be here and the door would open out and the hinges would be along this edge. I have a window here which has the V shape pointing down, which would indicate that this window opens out along a hinge at this point. Notice this note here. Submit an alternate proposal. Omit a 2 foot by 8 foot by 6 foot 8 foot exterior door in the rear and replace a 7 foot by 8 foot overhead door with two 3 by 6 by 8 foot exterior doors. So in other words, it appears that they're replacing these two doors, or rather omitting this door and replacing this entire door with two doors 3.5 feet wide by 8 feet tall. So they would be a bigger, they would fit this location, but they'd be two doors. So it looks like they might be two opening doors. Notice 3'6" times 2 would be 7 foot. So this entire space would be filled up with two doors, possibly open, hinged on this side and hinged on that side. On the front elevation, we have a door hinged on this edge. We have face brick, different type of brick than building brick, and we see that this portion is redwood siding. So there's a lot of redwood being used in this building, and that's what our elevation and our exterior drawings tell us. Insulation. Let's talk about insulation. Insulation is a barrier. Because of climate, you're going to have different building materials and construction methods that are used. The insulation acts as a thermal barrier. What we want to do is resist heat and cold transmission in and out of the structure. We may use insulation as a sound barrier, again, to prevent transfer of sound from one section of a structure to another. The different types of insulation might be loose fill, flexible, similar to the fiberglass bats or blankets that you might see between the studs in your wall or between the joists in your attic. FSK stands for foil scrim craft, which is how these are constructed. Craft stands for craft paper, basically the brown paper that you would often see in grocery bags. The foil and the scrim is a reinforcing fabric, and it basically provides the insulation with some fireproof characteristics. Then there's rigid. These are the plastic boards that you might see. And then there's foamed in place. And this is sprayed on, and again requires specialized protective equipment and installation equipment. Now, all these materials have something known as an R value, which is the measure of the ability of a material of a particular thickness to resist the flow of heat through it. If you look at some typical R values, you will see that lightweight concrete masonry units, basically cinder blocks, 12 inches thick, have an R value of 2.27. Gypsum board, half-inch thick, has an R value of 0.5. If I double the thickness of gypsum board and make it 1 inch thick, it will have an R value of 0.9. But notice fiberglass bats, the FSK we were just talking about, how much higher the R values are. And so the higher the R value, the greater the resistance to heat flow. When I put all these pieces together to build a wall, the wall has a total R value that includes the R value of the framing, any sheathing, any material in between it. So again, in CNST 2131, we talk about this in more detail, but keep in mind that that's why you see those sections and you see those different components to a wall section, because of this phenomenon. An exterior insulation and finish system, or an EIFS, is a system that consists of an insulation board, a reinforcing mesh, a base coat of an acrylic and Portland cement, and a finish coat of acrylic resins. Usually this is a rigid type, either extruded or expanded polystyrene. This provides the thermal insulation. It allows the coating to have some flexibility so it doesn't crack. It is attached to a wood or concrete or masonry substructure, and then we trowel this coating on to create a desired finish. It is a complete unit and can be used to provide the insulation necessary to a wall unit. And it is used in the Shaw Place condominiums. Now let's move on to those strange abbreviations we saw earlier. MEP, HVAC. MEP stands for Mechanical, Electrical, Plumbing, while HVAC stands for Heating, Ventilating, Air Conditioning. Together, these are sometimes referred to as the mechanical trades, and we refer to the drawings that show this information as mechanical drawings. We'll start with the plumbing. This is a single line diagram. Single line diagrams for plumbing and HVAC systems are used because they are normally not shown on residential like commercial prints, but this isometric drawing can be included to show the water supply and the drainage systems, and we are using a single line to represent each pipe in the system with nominal diameters shown. So we'll turn to brick veneer 4 for an example of what this looks like. I do want to point out, for those of you who ever get into the business of creating these drawings, this is an arrangement that I do not recommend. Notice the drawing is called the plot plan, but we have a bathroom elevation set of drawings. We have the light fixture schedule and the door schedule, all shown on a drawing called the plot plan. If you were the electrical contractor looking for the light fixture schedule, or the carpenter looking for the door schedule, you would not think to look on the plot plan. Oftentimes, designers will want to minimize the number of drawings, and they will fit information like this wherever there is empty space on a drawing rather than create another drawing. I believe it's a bad practice, and if you can, you should be able to avoid it, especially with today's AutoCAD systems. But it is a reminder of Rule 1 of print reading, is why you never accept a single plan out of a multi-drawing set. So let's take a closer look at this area of the drawing. We have here a water piping diagram. Notice it says not to scale. So whatever dimensions you might think this is representing, you cannot tell from this drawing. So we're going to look at each piece of it. This is the service. It's a copper pipe. It's 3/4 inch, and it is providing the water that is coming into the house. Now here we have something called a sillcock. Many of you may not know what that is, and we'll talk about it in a minute. From there, we move ahead. There is a 1-inch copper line that drops down into a water heater, and now a dashed line comes out of the water heater, feeding the sink and the dishwasher. Well, each sink has a hot and cold line. You don't need cold water to the dishwasher, hot water. So that tells us that this dashed line represents the hot water line. So let's take a look at those areas. Here's the dishwasher. Here's the water heater again. Now, when we turn to brick veneer 1 drawing and we look at that area, we see here the electric hot water heater. So this is where the water line is coming into and coming out from. And here we see the sink with its hot and cold, and the dishwasher. So that helps us get an idea of where this piping is going to. Looking at the rest of the single line drawing, we see tubs, WC, which is water closet, and lavs for lavatories. In the construction trade, toilets are water closets, sinks are lavatories. So just remember that, because we will see that many, many times. So looking at this area here, here's the washer, and here is the washer dryer in the closet. Notice I have tubs and my water closet and my lavatories. Notice the tubs have hot and cold to this side, hot and cold to this side. Water closets just have cold either side. Lavatories, hot, cold this side, hot, cold that side. And lo and behold, it lines up with the floor plan showing the arrangements to the bathroom. And then once again, we have something called a sillcock. And here we see on the outside of the building, at the end of where the bedrooms are, a sillcock. Going back to our sillcock on the entry side, we see that over here on the outside, again outside of the building, in the carport, is a sillcock. So what exactly is that? The sillcock is a water faucet placed at about the sill height, which is where the framing starts on the foundation on the outside of a building. And it usually has a threaded connection here that allows you to connect a hose to it. So it's sometimes referred to as a hose cock. Now, sometimes you will see a hose bib. And a hose bib is defined as an outdoor faucet that supplies water needed for outdoor chores. Notice it has a threaded connection where you can connect a hose to. The hose bib is often frostproof and might be abbreviated as FPHB, meaning a frost-proof hose bib. So, were they separated at birth? You will sometimes see references to a hose bib, sometimes references to a sillcock. Basically, they are an outdoor faucet. Keep in mind that the arrangement of the piping is to minimize the amount of piping. That's why the bathrooms are back to back. Everything is in a straight line. It provides economy in construction. It provides efficiency. All the water lines are in one location. Brick veneer 4 in the plot plan also calls for a sanitary system. Everything goes into a septic tank, and then there's a tile field for it to percolate out. A closed tile, 4 feet of 4-inch PVC connecting to the septic tank from the building. And we can see that drain tile surrounds the basement and goes into a settling basin and then into a sump pump. And the settling basin is to allow any dirt that is collected by the drain tile to settle out and then get pumped out into a 20-foot 1 1/4 galvanized steel pipe to 20 feet of drain tile. And so here's the connection for the drainage of the basement into the drain tile field. Moving on to electrical. Again, we need 2 drawings. Brick veneer 4 gives us the light fixture schedule, but brick veneer 1 will tell us where they go. Notice we have light fixture A, and light fixture A is a ceiling light in the bedrooms. Notice there's a little line drawn to the letter S. This is telling me that there will be a switch here that controls light A. Notice it calls out a model number, but we don't know right now what the manufacturer is of this model number. S means it's surface mounted, so it's nailed to the ceiling. Takes 2 60-watt lamps. We look at B, and we see B is in the hall, and that's 1 75-watt lamp, but there are 2 of them, not contained in the light fixture schedule. Would like also to draw your attention to light fixture B, showing connected to something called S sub 3 and a wire going off here. S sub 3 means it's a 3-way light switch. These are basically 2-way light switches, on and off. This is a switch, a 3-way switch that can be controlled from turned on and off here or on and off at another switch. M is the light over the lavatory. This switch here doesn't call out anything. I assume it's a fan. But notice for M, a $150 allowance to be selected by the owner. In other words, the owner can pick any light they want for the bathroom up to $150, and it will be included in the price of the house. If, however, the owner were to pick a light fixture more than $150, they would be responsible for the difference. These, again, another reason why we use symbols. This symbol here tells me I have an outlet. I don't have to call it out because the symbol tells me. But here in the bathroom, I have a GFCI, which is a ground fault current interrupter. This is a special outlet that is included in wet areas, such as bathrooms. I'm sure you've all seen the murder mystery where the villain dumps the toaster into the tub, killing the victim. A GFCI would prevent that by instantaneously interrupting the current when a ground fault, such as the toaster in the tub, is discovered. Here's the rest of the brick veneer house, and we see that a D is a recessed light, and notice I have multiple Ds, 1, 2, 3, each controlled by their own switch, and this one has a dimmer on it. Here's my L switch, or L light, right above the washer and dryer. Here's another GFCI outlet. I have 4x14 floor registers. This is for my HVAC, my heating, ventilating, air conditioning, but I don't have enough information to know how this gets routed back to the furnace in the basement. We have here porch lights controlled by switches. Here's the other end, S3 of the hall lights. Here's the kitchen light, and S3 as you walk in from the carport, or shutting it in the hallway. Notice the living room, I have a switch connected to outlets. These are known as switched outlets. So I can have lamps plugged in here, and as I walk into the living room, I throw the switch on, and these lamps will light without my having to walk through a dark room. Now, a few more things before we move on. The wiring simply tells me that this switch controls light E, which is 2 40-watt warm white rapid start. These are fluorescent fixtures. But it doesn't tell me what circuit they're on. Could this light be on the same circuit as these living room switched outlets? We don't have that information. So it could very well be being left up to the electrical contractor. Notice in closet D, there seems to be a light that says PS. Not listed here, but I would suggest that it being a closet, it means pull switch. And we're simply looking at a porcelain socket. Now, I have taught this class a number of times, and I have yet to find C, F, and G lights. So again, what happens when you're looking for the E light and you can't find it? Ask, coordinate, ask the questions. Here's L for in the carport. Again, three-way switch, pull switch, J, K lights. So all this, here's my electrical panel, but I don't know inside the kitchen, just inside the door right here is my electrical panel, but I don't know which one of these is connected back in what order. So just one thing to keep in mind. Week 8 is broken into 2 parts, and this concludes part 1. Please continue with the video for part 2.